network is poor network. Poor network. So express the following in standard form. Express the following in standard form. Which one public? Sequence on auto. Maybe I check this one. No, the chin. No chin. No the chin. Okay. Now, sorry, my network was poor. That's why I left. So I said express decimal numbers in standard form. Express these decimal numbers in standard form. So let's continue. Now looking at this, excuse me, I want to remove any distraction so far so I can concentrate. All right. Now, the question says express the following in standard form. And in standard form, I've already explained this to guys. If you are just joining for the first time, then after this video, for you to understand, you will still understand anyway. For you to get grounded on this, you need to go and watch part 1. I was doing this and network and something happened that I had to cut the live stream. So this continuation. All right. So we have done expressing whole numbers in standard form in the previous video. So this is another video. All right. So now we have 0.00163. Okay. So if you want to change a number in standard form, if you move your decimal point to the right, your n is what is going to be negative. If you move your decimal point to the left, I'm trying to summarize what we did the other time. If you move your decimal point to the left, your n will be positive. Okay, so if you move your decimal point to the right, your n is negative. If you move your decimal point to the left, your n is positive. Okay, and I also said in the other video, the previous one, which I still advise that you go to watch it so that you flow with what I'm doing. So if you want to express a number in standard form, that number must be written in this way: a times 10 to the power of n. It was written as a times 10 to the power of n. Okay, all right. And whereby your a is a number between 1 and 9. So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9. It cannot be 10. And your n is an integer, positive or negative integer. Okay, that is positive whole numbers and negative whole numbers. Okay, so that has summarized what we were doing initially. Okay, Oma, you can't find me on TikTok. It's well, my dear. I'll try my best to go live on TikTok as well. Okay, all right. So Now this is where we are. This is where we are. So having said that, to express these numbers in standard form, what I need to do is I need to write this in this form. A times 10 to the power of n, right? And my A has to be 1, 2, 3 to 9. 1, 2, 3 up to 9. Okay? It can be any of these numbers. So if I look at this number from here, you can see that we have 0.00163. So I need to get my A. I need to get my A. So to get my A, I need to shift this decimal point. 1, 2, 3. Now, why do I stop here? If I stop here, that means I have 1 point. My decimal point is now between 1 and 6. So I'll have 1.63. Now, why did I stop there? Why didn't I move forward to this place? Now, remember that if I take this decimal point to the other side, what I will have is 16.3. That is 16.3. If I should continue this particular transfer, if I continue to shift the decimal point, if I decide to shift it again once, I will now have 16.3. And remember that 16.3 is bigger than these numbers. So it cannot serve as our A. Are you getting it now? 16.3 is bigger than 9, so it cannot serve as our A. That is why we stopped at 1.6, because 1.6 is approximately 2, so it can serve as our A. You now understand, right? So that is exactly why I will now write my A now should be 1.63. So we are going to take this one. This is where we are. So we now have 1.63. 1.63. Okay, now it's time to get our n. It's time. I really miss my last audience. I don't know if most of them has joined this one as well. We were much then before the whole thing stopped, but as well. So you have 1.63 times 10. Now you check how many times did you move your decimal point and to what direction. So we move this decimal point from here to here. So we moved it 1, 2, 3. So this will be 3. Now, is it going to be negative 3 or positive 3? It's going to be negative. Why? Remember that this is the original position of this decimal point. So since we shifted it to the right 3 times, it's going to be negative. Assuming that this is a whole number, assuming that this is a whole number, okay, we would have shifted the decimal point to the left, and that is when we are going to have positive. Like I said, check my previous live. That is where we talked about changing whole numbers to significant figures so that you understand what I'm trying to say. All right, now the second one. For the second one, we have 0.0059613. If we intend to change this to a standard form, remember, we need to write it as A times 10 to the power of n. And our n, A must be between 1 and 9. It must not be more than 9. Okay? So we have 0.0059613. And this is our decimal point. So I will shift this 1, 2, 3. I'll stop here because when I stop here, I'll now have 5.9613. Yes, it should be. It must stop at this because 5.9 or this 5.96 is approximately 6, which is within this range 1, 2, 3. So it can serve as our A. We cannot shift the decimal point to this point because if we do that, that way we will have 59.6. And 59.6 is bigger than 9. Remember that our A shouldn't be more than 9. And 59 is bigger than 9 already. So that is why we cannot and we will not and we should not move this decimal point more than this point it is. Okay, so now we have 5.9. So it was here. We have shifted the decimal point to this place. So it's now 5.9613. Remember, pick all the numbers at the back of your number as long as it's not zero. Okay, so we're going to write this 5.9613 times 10 to the power of. Now we shifted our decimal point how many times? We shifted that 1, 2, 3, 3 times. So it's going to be 3. Now, is it going to be negative 3 or positive 3? So it's going to be negative 3 because remember, we shifted the decimal point from its original position. We shifted it to the right. So when you go to the right, your n is negative. When you go to the left, your n is positive. Okay? So that way we have minus 3 as well. If you have any question, you can drop in the comments. Okay? If you do, please drop in the comments. Like, comment, and share. That is if you love what we are doing. If you love it, if you don't love it, just tell us in the comments what we should do better. All right. So now we have 0.213. 0.213. So first of all, I will need to shift this decimal point. I think this time it should be once. So I will shift it once to get to 2.13. I shouldn't shift it to this side. If I shift it to the second one, I will now have 21.3, which is bigger than our 9. So it can only be 2.13. Okay. All right. So we now have 2.13. So we have 2.13 times 10 to the power of. So because we shifted our decimal point once to get to 2.13, it will be raised to the power of 1. Now, we shifted the decimal point to the right. So it's going to be negative 1. And that is it. Basically that. Remember what I said, that this standard form, we are going to go from 0 to hero. So this is the basic, and we are going to get to the hard part, or the part that is more difficult, whereby you are going to make use of all these small things you learned here to solve more complex questions without the use of a calculator. Okay, so if you have any question, drop. You started all over again after your phone fell on the ground. Oh, Amy, thank you. No, this is the continuation. Remember that this is the as a classwork I was writing when the phone fell down. Yes. So this is, I did not start all over. This is the classwork I was giving you that time when the incident happened. So I will take a step backwards. Take your screenshot, please, in 3 seconds so that we can move on. That is for those that are copying. 1, 2, 3. Okay. Now, like I said, you're going to enjoy this. Trust me. You're going to enjoy this class. It's going to be a sort of revision for those of you that have forgotten. And if you are in exam class, this is going to help you very well, especially when you are solving questions without calculator. All right, now, expressing standard form. What if a number is already in standard form and you are asked to write it as ordinary number? Expressing standard form to ordinary number. Now, okay, that number 1, I'm confused. How is it raised to the power of -3? Oh, and I'm just seeing this particular question. Okay, I'll get to you. Let me answer it, Amy. Amy, let me answer it. That number 1, right? You said that's number 1. You are confused. Let me check. The question for number 1 is in the classwork, right? The 0.00163. Amy, is it this one? Yeah, don't worry, let me use this to explain. Why is it 10 to the power of minus 3? Remember that we need our a to be between, okay, we need to express this in this form, a times 10 to the power of minus, sorry, to the power of n. Okay, so we need our a, and remember that our a is 1 2 3 to 9. Okay, so the first thing we will do is to get our a from this number, and we can get that by shifting our decimal point from its original position till we get to a. All right, so we are going to have 0.00163. So this is the original position of our decimal point. So we now shift it to get a, and a must be 1 2 3 to 9. So if we shift it to this place, we have 0 points. We've not gotten any number. So we have to shift to this point. We now have 1.63. So this is where our decimal point is now, 1.63. Now remember that we cannot put more than this position, because if we do that, if we decide to shift this decimal point to this place, we will now have 16.3, and 16.3 is bigger than these numbers here. Okay, so it cannot be used as a. That is why we must stop at 1.63, and 1.63 is a little bit lesser than 2. If you approximate this, you get 2. So it is within the range of our a. So that way our a now will be what? 1.63. Now you are asking why it is negative 3, right? Oh, you cannot see that clearly. Now let me check. Okay, so you are now asking why it is negative 3. It is negative 3 because to get to 1.6, we transferred this decimal point to that place 3 times. So we took the decimal point from here, 1 2 3. So it is 3 raised to the power of minus 3. And it is minus, remember, because when you take your decimal point to the right, your n has to be negative. So you can see that the decimal point was shifted to the right 3 times. So that is why it is negative. I hope that clears you now. Okay. But you said it's between 9, the point end. Whew, maybe this is not the one you're talking about. It's between 1 and 9. So we have 1.63. 1.63 is between 1 and 9. So Amy, I don't know if you are still, if you understood what I did, but if you don't, please take your time. All right? Go back to that first video. Watch it closely. I believe it will answer your question. Okay? All right. Now, I need to fill this ink. It's becoming faint. So we are going to talk about our expressing standard form to ordinary number. That is when a number is already in its standard form and you're expected to leave it in ordinary number. Let me fill this ink first, please. So to do that is the easiest question you can answer. Yes, that is the easiest question you can answer. That is when you move to the right, it is actually positive. When you move to the left, it is negative. This is what I mean. So for example, number 1, you have 60. You have 60. Now, this one I don't need to explain too much here. When you have a number that ends with 0, to express it in standard form, just write that number times 10 to the power of, if you have only 1 0, then it should be raised to the power of 1. So for example, if you have 600 now, it's going to be just 6 times 10 to the power of what? 2. That is it. Oh, we are expressing ordinary number again to standard form. We didn't do this. Now, we want to express standard form to ordinary number. Sorry, I'm repeating what I've done before. Okay, now let's look at some examples. Express the following in ordinary number. So this is what I'm supposed to write. 6 times 10 to the power of 1. 6 times 10 to the power of 2. Like I said, this one, you don't need to stress yourself. Anytime you have something like this, write the number. We have what? 10 to the power of 1 is just 10. That is just 1 0. Because in 10, you have just 1 0. As easy as that. This one is easy. Okay? If you have any question, please, you can ask. Now, for this one, you write 6. Now, 10 to the power of 2 means 10 times 10, which will give us 100. So we have 2 zeros, or this 2 simply means we have 2 zeros. All right? So just write your 6, continue with just 2 zeros. You get your normal form. Now, this is where you need to just be more careful. If you have something like this, it's very easy to change to ordinary number. Now, if you have 7.6 times 10 to the power of 3, 7.6 times 10 to the power of 3, and you are asked to change this number to ordinary number, you can see that it's already in standard form. Now, to ordinary number, this is 7.6. We are going to move this decimal point. It's already like this. We are going to move it to the right. Why are we moving it to the right? We are moving it to the right because you can see that our n is positive. You need to look at the power of your, at this power, which is your n. Our n is positive. And since our n is positive, it's telling us that this number is a whole number. It cannot be a number less than 0, less than 1. So it cannot be a decimal. So that way, that will tell you where to put your decimal point, where to shift it to. So because our n is positive, we are shifting to the right. Remember, this time around, the answer, your number is already in standard form. We are changing it to ordinary number. So when you look at your n and it is positive, it is telling you that this is a whole number. So because it's a whole number, you shift your decimal point to the right, positive to the right. So we do that 3 times. We have 1, 2, 3. Now you can see that here we have 6 here, but we don't have anything here and here. We are going to complete them with zeros. Is that clear? How about PROB? Please explain formula. Thank you. Whew. Please, you need to expatiate, like explain very well what you meant. Okay, maybe I'll consider that in my next live stream. Okay, so let's continue. Now we have 7600, and that will be our answer, 7600. Now, what if the decimal, okay, let's do another positive number before we go to decimal so that you see the difference. Now, what if you have 9.4 times 10 to the power of 6? 9.4 times 10 to the power of 6. So we have 9.4. Because this is positive, it means that we are talking about a whole number. So I'm going to move this decimal point to the right. I'll move it to the right 6 times. So I will now do this. 1, 2, 3, 4, 5, 6. So these places that are vacant, I'm going to replace those, fill those places up with zeros. So I'll have 1, 2, 3, 4, 5. I'm done. So that means the whole number is what we have, 94 with 5 zeros. 1, 2, 3, 4. So that becomes your answer. Yeah. Thank you so much, Louise. Thank you. Now, let's talk about decimal. How do you know that your answer is going to be decimal? For example, we have this number 1, this number 2, this number 3, this number 4. Okay, so for example, we have 4.56 times 10 to the power of minus 2. 4.56 times 10 to the power of minus 2. Now, when you look at this, Can you see something? You can see that this is what? Negative. This is negative. So it simply means that this number is what? A decimal. So once you see negative, you shift your decimal point this time to the left 2 times. Okay? So this is what we have. 4.56. I'll shift this 2 times to the left. 1, 2. So this is where my decimal point is. So what I have is 0.0456. Remember that the decimal point is no longer here. We have shifted this to this point. So what we now have is 0.0456. But you know, to write a decimal, you always see 0.021, 0 point whatever, 0 point. You cannot just see point whatever. It doesn't make sense in maths. So I will now write 0.0456, but I'll start it with 0 point, just to make it make sense. Don't mind me, I joke a lot. So I hope we are on the same page. Hello, Judstein, how are you? I hope we are on the same page. Yes, because that is what it should be. You can't just write 0.0456 and tell them, see, this is where my point should be. Why am I putting 0? Please put that 0 for them. Now I'm going to tell you the significance of that 0. I'm going to tell you the significance of that 0. Someone is saying something. You are missing a 0 on number 4. Yeah, I've written it. See a 0 here. We have, this is times 10 to the power of minus 2. Okay. So I'm not missing a 0 right there. So we are shifting this to the left 2 times. So we have 1, 2. This is where our 0 is. We have only one vacant position, which we need to complete with 0. All right. You're a good tutor. Thank you so much, Judson. So that is why you have 0.0456. Okay. Then, like I said, it doesn't make sense in mathematics that you say 0.0 something. You have to be 0 point something. So that's why we added the first 0. Now, I'm going to tell you the significance of that first 0. Remember that, if you can remember correctly, I don't know if you can still remember your place value. Your place value, 100 tens and units, tenths, hundreds, thousands. Do you still remember? 100 tens and units. Then you have your decimal point. You now have your tenths. You have your hundreds. You have your thousands. How did they even write that again? Okay. Now for your tenths, this means that here, if you write 0 point, for example, we wrote 0.456. It means that there is no whole number here. This 0 is telling us that the whole number value is 0. We don't have any whole number there. So that's why that 0 is important. But the first 0 here, okay, we have 0.04. The first 0 is for the tenth place value. That means we have 0 tenths. We have 400, and it continues like that. We are not here to do place value. That is actually for grade. That should be grade 5, if I remember correctly. So I'm just telling you why this 0 we added is important. We are telling them, see, this is not a whole number. In fact, we don't have any whole number value here. Everything we have is under decimal. Okay. Now, another example. Amy, how? I'm talking about the 9.4. That I'm missing a 0 in 9 point. Okay, you know, you just joined. I've cleaned a lot of things. I believe I cleaned that off when I was cleaning things. So that is it. Thank you. So because we shifted this to the right 6 times, we are going to have 5 zeros. Yes. All right. So let's continue. Thank you so much for bringing that to my notice. I did not even know that I cleaned that. All right. So let's do one more example on number 6. Number 6 says 9 times 10 to the power of minus 4. 9 times 10 to the power of minus 4. Now, remember, I've said that in the first video. So later, please, you need to check the first part of this live stream. There was a first part. This is the second part. So that is where I explained that when you have a whole number, all right, this whole number now, your decimal point is always at the end of the whole number. So for example, 9 is sent as 9.0. The decimal point is at the end. 2 is sent as 2.0. The decimal point is at the end. Okay, so that means what we have here is 9.0 presently. So 9.0. Now, because we have negative n, it means we need to shift the decimal point to the left. So it's indirectly telling us that, see, oh, this is a decimal, oh, this number is not up to 1, oh, you understand? So that way it's directing us to go to the left side of our number line. So we are going to take this decimal point from its original position towards the left 4 times. That is just what this power is telling us. So let's do that. Now, I'm talking about 9-4. Yes, I've done that already. Thank you. So we now have 1, 2, 3, 4. So this is where our decimal point is now. We have removed it from here. So we now have points. Now remember that all the vacant places, you need to replace them with zeros. So we have something already under 9. So this place is open, 0, 0, 0. So you can see that what we have is 0.0009. 0.0009. So we now write 0.0009. And that becomes our answer. You don't need this 0 here, okay, because this is a whole number. So you don't need 0 here. It's insignificant. So now we have 0.0009. Amazing, right? Do you have any question? I'm here. Don't mind me. Ricky, you're welcome. Bean Sprout, thank you so much for the compliment. Are you ready, guys? Remember I told you that this thing we are doing, it will seem to be very basic, like it's very simple. Now, why is JJ doing this? I'm doing this because it's going to be the foundation of some complex questions we are going to solve, where you're asked to solve those questions without the use of a calculator. All right? So I'll take a step back so that you can take your screenshots for those of you that want to. All right, so in 3 seconds, please take your screenshots. 1, 2, 3. All right. So what is it saying? Question 4 is wrong, ma. Question 4. How is it wrong? Please, let's do question 4 again. All right? And tell you why your answer should be this. Let me explain again. 9.4. We are shifting this decimal point to the right 6 times. That is what this 6 is telling us. We are shifting this decimal point to the right 6 times. So let's do it together, okay? So we have 1, 2, 3, 4, 5, 6. Okay? Remember that anywhere you have space, you need to fill that up with zeros. All right? So we fill it 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that will tell you that the answer is correct. Now, if you are doubting me, my love, this is what you need to do. Get your calculator, press this value, 9.4 times 10 to the power of 6, and check if this is what you will get or not. Then come back to the comments and tell me your answer. All right? You need to confirm with your calculator. Press 9.4 times 10 to the power of 6 and see if this is exactly what it will give you. It will give you 94 with how many zeros at the back? 5. Then come back and tell me in the comments. All right, my love, let's go to the next thing. Trust me, I would have taken maths if I were with you during my era. JC, it's well. Everything happens for a purpose, okay? Yeah. So with that, I know I can clean this now. I can clean this now. So for the next, whatever I want to do now, we need these laws of exponents. Okay, we need these laws of exponents. Now, these laws of exponents, we are still going into details, the laws of indices or exponents, but for now, we need to understand these ones for what we are about to do. Okay, before that, a little bit of classwork for those that are interested. Classwork. So you're asked to express the following in ordinary. I'll give you a few minutes, but I'll be here because I don't want those watching this as replay to get bored. So I'm not going to give you much time to solve this so that we don't have too much inactivity in the video. All right. So the question says express the following to ordinary number. Now, number one, we have 4 point, oh, this is one I did. We have 7.3 times 10 to the power of 2. We have 5.246 times 10 to the power of 3. We have 1.1 times 10 to the power of minus 4. And we have 6.3 times 10 to the power of minus 6. Okay, so these 4 questions now is going to be a classwork for those that really want to try this out themselves. So you can try this out and tell me your answer in the comments. Try this out, tell me your answer in the comments later. Okay, even if you don't want to do it now. Number one is 7:30. 1, 2. Correct. That's cool. Someone has said this is 7:30 and that is correct. We are going to see why the answer is 7:30 later. All right. Number 2. Yes, you are correct for number 1. Then number 2, what do you think the answer should be? Number 2 is 5246. 1, 2, 3. Perfect. Correct as well. 5246. I'm happy you guys are coming up with these answers very fast. For those of you that are just joining us, I don't really understand why, don't worry. I will explain the solutions later. Number 3. Judson is correct. Jesse is correct as well. Number 3, what's the answer, guys? Okay, number 3 says 0.000. That is 3 zeros at the back. Let me check. 1, 2, 3, 4. And that is correct. That is correct by Judson. 0. Hope you're not using your calculator. Please, you're not allowed to use your calculator. Please, you are not allowed to use your calculator. So Judson says 0.00011, and that should be correct. All right, number 4, Judson says it's okay, Miss Tura and Judson, did they write the same thing? Let me check. 1, 2, 3, 4, 5. 5 zeros at the back of 6, and that is correct. 0.1, 2, 3, 4, 5. Then we have 6, 3. That is perfect. I'm so happy for those of you that we are able to tell us. Jesse says is 1, 2, 3, 4, 5. It should be 5 zeros, right? 1, 2, 3, 4, 5. Should be 5 zeros. 1, 2, 3, 4, 5. Yeah. 1, 2, 3, 4, 5. That should be the answer. If your own is more than 5, the zeros are doing me somehow on the eyes. I can't actually count it from the phone. Please, your zeros should be 5. Now let's check why these answers are correct for those that are just joining. So this is the classwork based on what we just finished. We have 7.3 times 10 to the power of 2. Now the power is telling us if this answer is going to be a whole number, or if it's going to be a decimal. So because the power is positive, it's telling us that this number is a whole number. So it's going to get larger. If we convert it to ordinary number, it's going to get larger. So that means because this is positive, we are going to shift this decimal point to the right 2 times. That is what the power is telling us. So we have 7.3. We shift it to the right 2 times. 1, 2, 3. Now we have space here, nothing is here. Just fill it up with zeros. Oh, sorry, we are shifting to the right 2 times, not 3 times. I'm sorry about that. So we have 730. So that is why you got 730. The positive 2 is telling you you are going to go to the right 2 times. That's all. Interesting. Now the second one is 5.246 times 10 to the power of 3. You can see that this 3 is also positive, right? Yes, it's also positive. So it means we are shifting this decimal point to the right 3 times. That is the meaning. We are shifting the decimal point to the right 3 times. So we now have 5.246. To the right 3 times, we have 1, 2, 3. You can see that there is no space where we can add 0. Everything is occupied. So that's why the answer is 5246. 5246. All right. Now the next one we have 1.1 times 10 to the power of minus 4. 1.1. Now negative 4 is telling us, see, I'm a decimal. Oh, you people should not move me to the right. Please take me back. I'm a decimal. So negative is telling you are going backwards. Positive means you're moving forward. In life, if you're moving forward, you are moving into positivity, right? Then for those that, God forbid, one is going to move backwards, but backwards means negativity, right? So that is what this is talking about. This is negative. We are moving the decimal point backwards. So we do that 4 times. So this is 1.1. We do that 4 times. 1, 2, 3, 4. So this is the present position of our decimal point. Now remember that we have space here. This place is already covered with 1, so we don't have any problem here. So we need to fill this up with 0, this with 0, this with 0. But I said something in the video. Remember that it's going to be 0 points. So even though this is your decimal point, you need to add this 0 to show that there is no whole number in this particular number. There is zero whole number. Everything is in decimal. So that is why you have 0 points and you have 3 zeros here. And that is why that answer is also correct. So the last but not the least, the same thing. The last one is minus 6. So this is the position of the decimal point. So negative 6, go back 6 times. So we go back 1, 2, 3, 4, 5, 6. This is where our decimal point is. Now always remember to put your 0 point to show that there is no whole number here. So we replace this with 0, first 0, second 0, 3, 4, 5. So that is why you have 5 zeros here before your word 6, 3. Okay, any question, guys? Do you have any question? I believe you don't have. Any question. All right. Now, I said we are going into, okay, please take your screenshot in 3 seconds, please. In 3 seconds, take your screenshot. 1, 2, 3. All right, thank you. So I'm going to introduce some laws of indices or exponents that is needed in this particular part we are about to enter now. Some laws of indices and exponents. So the first one will be the multiplication law. This is still under standard form anyways, so no need. Now, the multiplication law says that a to the power of n multiplied by a to the power of m is equal to a to the power of n plus m. It says that a to the power of n times a to the power of m is equal to a to the power of n plus n. Now, remember that if you see a number in its exponential state, it consists of its base. For example, 2 to the power of 3. This is the base, and this is the index, or the exponent. Okay. Now, when the base from here, you can see that the base are equal. We have the same base here and here. So when you have two numbers that have the same base, they share the same base. For example, you have 2 to the power of 3 times 2 to the power of 2. You can see that they share the same base and they are multiplying each other. Okay, that is what this law is saying. So number one, they must share the same base. They must share the same base. Then number two, it must be multiplication, not addition, not subtraction, not division. Now, when you have something like this particular law is telling us that all you need to do is you pick one of the base, which is 2. You add the powers, 3 plus 2. Okay? So that way your answer is 2 to the power of 5. Now, let us prove that this is correct. Anastasia, hello. Yeah, Vast, how are you? So, what we are saying is this. Let's take, for example, let's solve this without this law. If you have 2 to the power of 3 and you want to multiply it by 2 to the power of 2. Now, 2 to the power of 3 simply means 2 times 2 times 2. That is the meaning. 2 times 2 times 2. Okay? Then times 2 to the power of 2 means 2 times 2. Now, if you notice, you notice that you have 2 to the power of 1, 2, 3, 4, 5. 2 to the power of 5. Now you can confirm that you share the same answer. So what this law is telling us is simple. It's saying, see, instead of you to waste your energy multiplying this continuously to find your answer, once the bases are the same and they're multiplying each other, it now says, dude, just take one base, bam, add the powers, simple. Don't stress yourself. One thing about mathematicians is that we are lazy, very lazy set of human beings. Yes, so if you want to be a good mathematician, you must look for those lazy means to solve your maths. Okay, all right. So that is it for the first law. Now the second law is like the opposite of the first law. Excuse me. Remember that we are learning this because we want to use it to solve some complex questions. Okay. Now this one says a to the power of n divided by a to the power of m is equal to a to the power of n minus m. Now, this is the opposite of the first one. All right? Is the opposite of the first one. So what this is saying basically is if you have 2 to the power of 5 divided by 2 to the power of 2, that you pick one base, which is 2. You subtract the powers, 5 minus 2. So it will give you 2 to the power of 3. That is what this law is saying. You can still verify. Now, there is one mistake that students normally make, and I want to correct that. I'm here again. So, okay. So, like I said, the students normally make this mistake. For example, if I say 2 to the power of 2 divided by 2 to the power of 3, if they want to apply this law, okay, if they want to apply this law, they will pick one base, they will subtract the powers, they will still say 5 minus 2. And this is wrong. According to this law, it must be they'll subtract the second from the first. Whether the second is bigger or smaller, whether the first is bigger or smaller, it doesn't matter. The law says subtract the second from the first. So even though 2 is smaller than 5, we must subtract 5 from 2. So it has to be 2 minus 5. So that the answer will be 2 to the power of minus 3. I hope this is clear because students make this mistake a lot. So if you are a parent, you are taking down this note for your child, ensure that you tell them this so that they don't continue this mistake. Please, Scientist Arena, I don't understand what you mean. You can send me an email, please. Just go through my page, send me an email, and we talk from there. Okay, now let us prove this law. We have not proved it yet, right? Yeah, let us prove this law. So this law says 2 divided by 2 to the power of 5 divided by 2 to the power of 2. So now we have 2 to the power of 5 means 2 times 2 times 2 times 2 times 2. I don't know if you can still see that. Okay, you can't. Let me shift it a bit. All right. So now you can see that. So we have 2 times 2 times 2 times 2 times 2 into 5 places. Okay. So you divide by 2 to the power of 2. That is 2 times 2. All right. So this is saying, normally what we will do now is this will divide itself 1. This will divide itself 1. So we are left with 2 times 2 times 2. That is the same thing as 2 to the power of 3, which is what we got using the law. So this law is telling us so I'm sorry about that. We no longer see the board. Okay, can you see the board now? I believe you can see the board now. It's my phone signaling that it's already my phone's the battery is low already, but we need to, yeah. Thanks for the confirmation. Thanks for the confirmation. I believe you can see it now. So like I said, this is it. If you do it manually without using this formula, you are still going to get the same answer. So this formula is telling you basically you shouldn't stress yourself when numbers in the same base are dividing each other. All right. So now let's introduce the third the third law that we are going to make use of. The third law we are going to make use of is this. A to the power of m raised to the power of n is equal to a to the power of m times n. A to the power of m raised to the power of n is equal to a to the power of m times n. Now we are going to make use of another example. I'm a 40 years and I'm learning. Thank you so much, sir. Thank you for joining. Now, this particular law is telling us that if you have something in this form, for example, have 2 to the power of 3 raised to the power of 2. It says that you should solve this as 2 to the power of 3 times 2, which is same thing as 2 to the power of 6. That is just it. So 2 to the power of 3 raised to the power of 2 is the same thing as 2 to the power of 6. Now let us try to prove this normal, that is without the law. Now what is 2 to the power of 3? We have 2 to the power of 3 raised to the power of 2. That means we need these 2 times. Now if you count, you have 1, 2, 3, 4, 5, 6, which is same thing as 2 to the power of 6. So that is basically Do you have another law I want us to talk about now? No. There are other laws of indices, but based on the topic we are doing now, I think this is the three that we need to understand very well. Okay? All right. I'm a teacher as well, but not for mathematics. Wow. I'm glad to meet you. Thank you so much. Okay. So, any question? I don't think we have any question, right? Okay. So, now let's solve one example using these laws. That is, remember that we are still in standard form. We are still in standard form. Now, what if you now have a question? Remember, you'll be told without the use of a calculator. Without the use of a calculator. So let's go first. So without the use of a calculator, express the following in standard form. Express the following in standard form. Okay, now the question says, excuse me, I need to fill this in. Someone says, please, how long have you been teaching on YouTube? I also want to teach math now. Please, you can send me an email. I'll give you detail, everything you need to know. All right. So it's a matter of, it's easy, seriously. As long as you have the passion for it, it's very easy. All you need to do is just put your heart to it. Send me an email. We'll discuss from there. So express the following in standard form. Now this one says 0.00216 times 10 to the power of minus 7. You are asked to express this in standard form. Now, the first thing you should notice here is simple. The first thing is that this first number is not in standard form. You can see that this is ordinary number. Now, remember where we are coming from. We've talked about how to change a decimal just like this in standard form. We've talked about how to change a whole number to standard form. So the first thing we need to do is to change this to standard form. Now, remember that we have 0.00216. If you are just joining, you can still watch this as a replay or watch the first live, the part 1 as a replay. All right? So someone says, hello, ma'am. I'm so poor in maths, but I love maths. I wanted to learn from the beginning. Okay, you are welcome. You're on the right place. You are at the right place. So we need to change this to standard form. Remember, for this to be in standard form, it needs to be in this way. 8 times 10 to the power of n. Now our a has to be 1, 2, 3 to 9. It shouldn't be more than this. Okay, and our n has to be either positive or negative integer. So our a in this form, we need to shift this decimal point till we get to a number that is within this range. So we go 1, 2, 3. So I'll stop at 2. This is because this will now give me 2.16. This will give me what? 2.16. And remember that 2.16 falls within this range. So I cannot say 21.6. No, it will not work. Because 21.6, that is if I decide to change this decimal point from here to this side, I will now have 21.6. And 21.6 is bigger than this number. So it cannot serve as my A. So that means my A now is 2.16, right? So I'll now write 2.16 times 10 to the power of. Now remember that if you are changing a number to standard form, if you move your decimal point to the right, your n becomes negative. If you move your decimal point to the left, your n becomes positive. So you can see that we shifted this decimal point to the right. How many times? 1, 2, 3. So it's going to be negative 3. Another way to do that is once you see a decimal, then your n is definitely going to be negative. All right. So now we have 216 times 10 to the power of minus 3 times 10 to the power of minus 7. Now, what do we do next? This will be equal to 2.16 times. So remember our multiplication law that I just introduced. Do you understand? Ma, do they teach this in university too, or is it in another form? In university, even if it's coming in university level, it has to be in an extended way. Maybe it's connected to a topic you are doing there. If not, this is basics. All right. Okay. Now we have 2.16. So we have 10 to the power of minus 3 times 10 to the power of minus 7. So they share the same base. Remember that a to the power of m multiplied by a to the power of n is a to the power of m plus n. Okay. So that means we are going to pick 110 just as this. We pick 110. Then we add the power. So it's going to be minus 3 plus minus 7. Okay. We add the powers. Someone is saying confusing. Okay, let me see where you are confused, sir, so that I will clarify you. Tell me where you don't understand, I will clarify you. Okay, now this will be equal to 2.16 times 10 to the power of, now we have minus 3, plus times minus is what? Minus, right? So we have minus 7 again. So our final answer now will be 2.16 times 10 to the power of minus 10. And that becomes our answer. Very easy, right? Very easy. Okay, so can you solve this for me? And this becomes assignment because this I need to go right now. My kids will soon come back from school. So you are asked to express in standard form 0.0024 times 0.64. Can you do that? Let me give you a hint. First, you need to put this in standard form. Then you need to also put this in. Okay, let me not confuse you. Let me start small. We are just going to graduate to something bigger. Okay, so let me put something here. Say 10 to the power of minus 2. So that it can be in the same category with this. Let me not confuse you. All right, so this is what you need to write for me in the comments, your answer to this. So I'll be waiting for you in the comments, on the comments. All right, thank you so much for joining, and we are going to see ourselves next time, right? Yeah, bye.